And welcome again to the Simpkins Physics Corner. It's your host, Mr. Simpkins, with some physics in a corner. Today's topic is projectile motion, more specifically angled projectiles. I'm going to walk you through a problem with angled projectiles. I'm going to show you how to make your calculator solve the quadratic formula for you. So without further ado, let's jump into it. Now in AP Physics, the first part of our problem solving strategy, the first step, is to understand the question. So a cannon is launched at 53 degrees at a speed of 90 meters per second from the top of a cliff. The cliff is 25 meters above a ravine. The cannonball lands on the other side of the ravine on a plateau that is 9 meters above the ravine. How long is the cannonball in the air? How far does it go? And what's the apex or the highest point in the cannonball's flight? So understand the question. Second step is to draw the question, set a coordinate system, and determine where your origin is. So I have a little cannon here. It's going to shoot a cannonball. That's an approximate drawing here, but of 53 degrees, and it's going at a rate of 90 meters per second. But we notice this velocity is neither horizontal only nor vertical only. It's actually a little bit of both. So we'll talk about what to do with that in just a second. It also says this cliff is 25 meters high. It says this cliff is 9 meters higher, this plateau, I should say. And it's going to go up and it's going to come down like this. We expect our projectile to follow that parabolic path. So anytime we realize, hey, this is a projectile problem, we want to make our x, y, t table. Because for a projectile, we know that although the motions in the horizontal and vertical directions happen independently, meaning gravity doesn't affect our horizontal motion, and our horizontal motion doesn't affect the rate at which we move up and down, although the x and y motions happen independently, they happen simultaneously, meaning at the same time. And since they happen at the same time, our x and y, though separated, happen at the same time. It's the x, y, t table. So this is how we're going to organize our information. The second instinct we should have for a projectile problem is, if it's at an angle, the first thing I need to do is find the vector components. So if this is our vector, our y component of the velocity would be found by doing v sine theta, y sine. And our x component of the velocity would be found by doing v cosine of theta. So let's go ahead and do that real quick. Vy is going to be equal. Now when I plug this in, it's going to be 90 sine of 53. So I'll show you that real quick. 90 sine of 53. And that is going to be for our y component of velocity, 71.88 meters per second. Do the same thing, or a similar thing I should say, but 90 cosine of 53 for the x component, and our x component of velocity is 54.16 meters per second. Now as a side note, you notice that whenever the angle is above 45 degrees, we're pointing more upward than we are outward. And you see that here, we have a higher vertical component of velocity, 71 in the Vy, versus the Vx is only 54. The horizontal component of velocity is less because we're at an angle that is steeper than 45 degrees. Now, for a projectile flying through the air, it's going to be under the influence of the force of gravity, and so it's going to experience an acceleration in the y direction of negative 9.8 meters per second squared. As part 2 of our problem-solving process, I should go back and say that positive we'll call up in the y direction, and we'll call in the x direction positive to the right to find our coordinate system. Now, this is not a whole lot of information, but if we look back at our drawing, we've organized this. We see that our final height, meaning at the end of the problem, our y final is going to be 9 meters. As a side note for this video, I'm using the variables that are consistent with the College Board AP Physics 1 equation sheet, so it's consistent. The initial height is 25 meters. So I'm going to write y initial equals 25 meters. And that's all the information we have to work with. Now, a lot of times in these word problems, it will ask you for something in a particular order for a reason. In other words, if it asks you for how long is it in the air first, it's probably because you should solve for it first. So how long is it in the air is going to be related to time. So we got to solve for the time it takes to go up and come all the way back down and land over here. Now, the hardest thing about physics sometimes is what equation do I use? If we look at our AP Physics equation sheet, here are our kinematic equations. And it looks like we need to find one with a t, with time in it. Now we notice the first two equations both have time, but the problem with the first equation is that we need this Vx. Now, keep in mind, any x here can magically be transformed. If we transform all of them into y's, it would apply in the vertical direction for our kinematic equations. They just didn't bother to rewrite it again since it's the same equations. So we can use the Vx, and we can just substitute as a Vy and use it for the vertical motion. The The problem here is we don't know how fast it's going Vy final. We don't know how fast it's going vertically when it hits the plateau. So that rules out the first equation. Even though it has time, we don't know time and we don't know the final velocity, so we can't use that one. So this brings us to our second equation. So what I'm going to do is rewrite it in terms of y here. So it would be y equals y initial plus v initial yt plus 1/2 a yt squared. All right, so that's from our equation sheet, our second equation rewritten in terms of y. And the reason we're using this, we can double check here, make sure we have everything we need. So the y would get 9 meters equals the y initial would get 25 meters. The plus v initial y, that's actually, I should have written it over here, that's our initial y velocity because it's our y velocity as we were being launched at the beginning of the problem. And so that's going to be 71.88 meters per second times t, we don't know, plus, I'm running out of room here a little bit, but let's see if I can fit it, 1/2 of negative 9.8 times t squared. Just barely fit it on the screen there. Right, that's a 1/2, a little tough to see there, but we'll see what that looks like in the next step. Good. So t is the only thing that we don't have. It's the one thing we want to solve for. And since we have all the other information, we've chosen the right equation. Let's go ahead and do a little algebra, a little simplification. Notice this is a negative 9.8 because our acceleration is down, and we have chosen up as our positive y-axis on our coordinate system. I'm going to do a little bit of sleight of hand here, a little rearranging. This would simplify to negative 4.9 t squared. This would simplify to plus 71.88 t. And this, if I wanted to set this equation equal to 0, I would need to subtract 9 from both sides, and 25 minus 9 would get us 16. So I'm going to put plus 16 over here equals 0. Now, if you're looking at that and you're thinking to yourself, that looks like the quadratic formula. Yeah, that's because it does. Or at least it looks like something that we could use the quadratic formula to solve. So let me show you how to use your calculator to make it to let the calculator solve this for you. All you would do is type in negative 4.9. Instead of t, if you're looking for that button, you actually use this button right under mode, that one, and you square, and then you would do plus 71.88 x plus 16. So we type that into our y equals button. If you tell the calculator to graph it, it's going to go ahead and graph it. And you'll notice it comes through the x-axis here, but we don't see it come back. That means we probably have to zoom out real quick. Let's see if we can find it by zooming out. There it goes up through the x. Ah, there it goes. So that's what we're looking for. We want the calculator to tell us where does that cross the x-axis. The reason is, look, that's where it would be equal to, that's where y would be equal to 0, and we've set this equal to 0. Oh, we want it to second calc, hit the second key and the calc key right here. Second calc, we want it to find that value where it crosses the 0. Now you'll notice this little blinky thing here, and it says left bound. It wants me to put this little blinky thing just to the left of that axis intersection. So I'll use the right key to kind of toggle over a bit here, and eventually I'll get to, I might have actually gone too far. Let's see, it goes quick. So you see that right there? That is to the left of the 0. Hit enter to make that your left bound. For the right bound, go to the right of it. And then for your guess, hit enter one more time. You'll see that it's now found a solution for us. T equals 14.89 seconds. And therefore, we've used the calculator and our kinematic equations to help us solve for the first part of this question, which was how long is the cannonball in the air? So I'm going to add this right here and say our time that is in the air from the time it's launched to the time it hits the plateau is 14.89 seconds. That's part 1. Part 2, how far did the cannonball travel horizontally? Now, you have to keep the big ideas of projectiles in mind. What can we say about the horizontal velocity of a projectile? Oh, since there's no horizontal forces, if we neglect air resistance, of course, there's no horizontal forces, there's no reason for the velocity to change at all as it flies through the air. So what that means is our horizontal velocity for a projectile stays the same the entire part of the flight, which means if I'm moving horizontally at this rate for this much time, then all I have to do to solve for the distance that we travel is use the definition of velocity. The definition of velocity is displacement over time. So therefore our displacement or our range or our distance that we traveled would be found by doing Vx, our horizontal velocity, times the time we were in the air, which we just solved for over here. So we just do 54.16 meters per second times 14.89 seconds, and we would get a big number. Let's see what that number is. Grab your calculator,
Get myself out of the graphing mode here. 54.16 times 14.89. It looks like we are going to be moving 806.44 meters away from where we started. So that's how far did the cannonball travel horizontally. Cool, we knocked out 2 parts. Let's do the last part. What is the apex of the cannonball's flight? By definition, the apex is the highest point in your flight. Now, depending on how you chose your origin, see, I chose my origin as the y height equal to 0 is the ground. Some of you may have picked the plateau as that. That's fine. Just make sure that when you give your answer, you're giving the answer for how far it is to the ground. If I wrote this question, I would have been a little more specific, but I stole it from somebody. So if it asks for the apex, it's usually asking what's the maximum height that we reached. So we want that right there. Now, in order to get that, we know something very special happens at this point in a projectile's flight. Since you're not moving up and you're not moving down, you take an instantaneous vertical break. Imagine tossing a ball. You toss a ball up in the air, it's going to stop for a split second. Well, that's where its Vy is 0. So at the top, Vy is 0. And that's going to be an important thing to consider as we solve for this part here. Our Vy is 0 at the top. So I'm actually going to do this a little bit separate of this XYT table because this is kind of all linked together. This is a little bit separate of a motion. In fact, I'm going to go like this and do it right over here. What I'm saying here is at the top, our Vy is 0 meters per second. At the initial launching point, we've already found that our V initial Y is 71.88 meters per second. We don't know how long it takes to get there. We do want to know what is the Y when we get there. We do know the Y initial was 0 meters. And let's see if there's anything else. Actually, our Y initial was not 0 meters. Our Y initial was actually 25 meters because we launched from the top of the cliff. We also happen to know that we have acceleration in the Y direction of magnitude 9.8 due to gravity. Okay, cool. So those are our known pieces of information. We want to know what is the apex height? What is the Y? So if I go to my equation sheet, you'll notice in my list of knowns, I don't know time. I don't know how long it takes to get there. So I'm going to skip over the first 2 equations because they both do have time. And what I'm going to ask myself is, can I use this equation to solve for one of these heights? Remember, all these x's can be transformed into y's if we do it consistently and we apply this equation vertically. Let's see what happens if we rewrite this equation in terms of y. Sorry about the whiteboard etiquette here, if you will. I'm going to do it right over here. We have Vy squared equals V initial Y squared plus 2ay times y minus y initial. And if we start plugging stuff in, we quickly realize, you know what, we do have enough information here. We have 0 squared equals 71.88 squared plus 2 times negative 9.8. Our y is what we're looking for, and our initial height was 25. And all we have to do is use some algebra to solve for this. So it's pretty quick steps from here. We do 71.88 squared, and that turns out to be a pretty big number. And that number would be 5166.7 minus, we'll do 2 times 9.8, which we're pretty familiar with because we do it all the time. We know that that is 19.6. And that's times the quantity, y minus 25. So you got to flex your algebra muscles a little bit. Subtract 5166 from both sides. Set that equal to negative 19.6 y minus 25. We're going to divide both sides by 19.6. I'm sorry, 19.6. Negative 19.6. I'm going to scoot our paper up just a tad so you can see the rest of this problem. And that's going to leave us with 5166.7 over 19.6. Leave us with 263.6 equals y minus 25. Add 25 to both sides. And it looks like our y, the highest height that we reached, again, we're referencing the bottom of the ravine for this one. Looks like the highest height that we reached was 288.6 meters. And now we've finished the projectile problem. So to recap, draw the problem first. Always get the x and y components as quick as you can. Make your x, y